Hello and welcome to the solutions video for our February 10th assessments. So you'll notice, since our last time, SmarterMarks has a few updates here. You can turn annotations on and off. So now you can basically work with pens and highlighters and such while you're doing the question. So you can highlight the key words and underline. So just some nice new features to help you get through the assessments. Anyway, our first one, find the greatest common factor and least common multiple of 24 and 60 using prime factorization. This means you are going to have to show work. So it's only partial credit if you just spit out the GCF and the LCM. You also have to show the prime factorizations both for full credit. So 24 is 2 times 12. But 12 has another factor of 2. So it's 2 times 6. 6 has another factor of 2. And then 3 is prime. Now 60. That's 2 times 30, which is 2 squared times 15, or 2 squared times 3 times 5. And 2, 3, and 5 are primes. So here's our two prime factorizations. The greatest common factor takes the lowest exponent we see of each. So that's 2 squared and 3. So our GCF of 24 and 60 is 2 squared times 3, 4 times 3, and that's 12. And our LCM of 24 and 60. For least common multiple, we want the highest exponents we see. So that's 2 cubed times 3 times 5. Didn't want the division there, sorry. That's 8 times 15. And 8 times 15 is 120. So we should be able to confirm that. This one is definitely 12. All we've done is add one factor of 2 and one factor of 5. 5 times 2 is 10, so 120 makes sense. Now here, cube root of 72. 72 is 8 times 9. 8 is a perfect cube. 9 is only a square. So it's actually the factor of 2 that gets pulled out. The 3 stays in, but we're only asked for that coefficient when it's simplified as a mixed radical. Now, which benchmarks should be used to estimate the approximate square root of 315? So the benchmarks, we're looking for a perfect square below 315 and another perfect square above. So looking at these, 100 is a perfect square, 1000 isn't. That's not useful. 100 and 400 are both perfect squares, but we want it closer than that. This will give us a 10 and a 20. And that's not great for approximating the square root. Now it is between 256 and 344. So while that functions, that still gives us quite the range. 256 is 16 squared. And I don't think 344 is a perfect square. Quick calculator check. Yeah, it's 2 root 86. But the 289, that's 17 squared. And the square root of 324, I believe, is 18. Yeah, so 17 squared, sorry, and 18 squared. So these are our two. I'm just going to, as we go, because I'm also using this to check performance, every time we complete a curricular outcome, I'm just going to double check what scores we have, mark the written response, and check the outcome scores to make sure the answer key is keyed correctly. Now here in a diagram, we can't really do a diagram here, so we're going to have to do it on paper. But we're representing the relationship between the real numbers, including the natural whole. I've actually rephrased this one. It should be give one example of each. So I've rewritten the text since I generated this. But we're going to have a big circle. And that's the reals. In that, we'll have the rationals and the irrationals. That's the Q with the line above it. They don't overlap. Every number is in one or the other. But the rationals include the integers, which are either I or Z. It's I in our provincial curriculum, but Z is the one used by the actual professionals. And those include the wholes, and I should have started bigger. The wholes include the naturals. So then N naturals is inside the W for whole, inside Z or I for integers, inside Q for rationals. Q for irrationals does not overlap, or Q bar does not overlap with Q. They're all inside the reals. So a natural number could be 1. Something uniquely whole is 0. And integer, so I or Z, that could be -5. Rational. The rational could be 1/2. And the irrational, so I'm going to say not Q, that would be pi. And the real number could be anything, right? Anything on that number line. In fact, aside from the irrational, we could have used 1 as the example for everything. There is no overlap between the rationals and the irrationals, but every natural is a whole. Every whole is an integer. Every integer is a rational. Every rational is real. Every irrational is real, but the irrational and the rationals don't overlap. So you could have used 1 example for 5 of these and had something separate for the irrationals. Now, we want to order these irrational numbers from least to greatest by comparing the radicands of the entire radicals. So that's a show work problem. So 6√2. If we bring the 6 inside, we have to square it. That's going to be √72. 4√5. We bring that inside. 4 squared is 16. 16 times 5 is 80. 3 times 7 is 63. Or 3 squared times 7. If we have 3√7, that's √63. And finally, 2√17. That's going to be 4 times 17, which is 68. So now we want to compare them least to greatest. What I recommend, most common issues with something like least to greatest or greatest to least, often students get confused and do the wrong sequence. So instead of just listing them, I would actually put the inequalities there. If we have the inequalities there as we're going through, and I'm putting those, I want it as they're expressed here. So I want to say 3√7, which is √63, is less than 2√17, because that's √68. That's less than 6√2. And that's less than 4√5. So now, because I have the inequalities there, everything should work out in terms of greater than, less than. That's one where even if they say greatest to least and you do least to greatest, but with the proper inequalities in the proper sequence, it's much easier to get marks or possibly even full credit. All right, that's our AN2. Now AN3, we want to simplify this. We have the 8th root of a square root of x to the 5th. So we're still going to have a 5 in the numerator. This is checking to make sure we understand the root is like a denominator in the fraction of the exponent. So this is going to be 5 over 2 times 8, which is 5 over 16. Now the cube root of 343 This is something that our calculators can do. So on the TIs, it's under the math menu, but that will be 7. Right? 7 times 7 is 49, times another 7 is 343. When 10 to the 1/2 is written as a radical, what is the index of the radical? The index is which root you are taking. This is a square root, so the index is 2. Which of the following is equivalent to 7 to the negative 2? Negatives move us to the denominator, so it's 1 over 7 squared, which is 1 over 49. And an equivalent form of 125 to the negative 2 over 3. Well, 125 is 5 cubed. So we can get rid of that 1 5 and say this is 5 to the negative 2, which means it's 1 over 5 squared. So that wraps up AN3. Nobody requested AN4 or AN5 this time. We did have RF1 through RF8, which we have covered in class, as well as people requesting early assessments on RF9, as well as measurement 1 and 2. So which bar graph best shows the number of rows used for each vegetable? If you want a raw number, you want a bar graph. So it clearly shows the numbers on the y-axis, not because it shows the vegetables so clearly, right? Those words are there. If you want to use the fraction in the garden, that's what pie charts are for. They're effective at proportions and only proportions. So we want the circle graph because it shows the percentages of the fractions, not because they add up to 100%. Now, which is the best fit for this graph? Right. We have the speed of a car versus time over the course of a day. That's going to be erratic. Temperature of a teacup as it cools down. Let's start with that. That's graph A because it's going to go smoothly. Height versus time graph for a bungee jumper after a jump. That's going to be B, where it regularly goes back and forth. Human population of Earth versus time. We are generally increasing. And the speed of a car versus time of day, that is also very erratic. It depends on where you're going, what your goals are for the day. Now, a coach is checking the statistics on a player who wants to know whether the player is making progress over the season. Is this the graph the best to use? So it's baskets scored. We have number of baskets versus game. And yeah, it's because you can actually see the trend. Right? The student is doing, or this player is getting better each time. So next, which shows the association is less than? So this says 9 is less than 11. It is not less than 9. That one's out. 9 is less than 11, 14, and 18. 11 is less than 14 and 18. 14 is less than 18. So we have the 3 for 9. 11 is not less than 11. It is less than 14 or 18. 11 is not less than 9. So confirmed, it is 13. Now, which of the following are functions? So, 1, we have no repeats on the x. That's what is key. If we have the same x, it must have the same y. If we have the same x with different y, it's not a function. 2 is a function, because that is a linear graph that is not a vertical graph, where it's not just x equals constant. So that's a function. 3 fails the vertical line test, not a function. 4 is a function because we never have more than one arrow coming off the same x. Yes, x of 1 equals 6 and x of 2 equals 6. That's okay. What matters is that we don't have x of 1 going to y is 6 and y is 7. So here we want to name, describe, and justify the test to find if a relation is a function. The name is the vertical line test. Describe. Draw a vertical line if it intersects the graph more than once anywhere, the graph fails. And justify. So why is this the right test? Why do we know that it works? That's what this is asking. Okay, it's not letting me go up. Is that because I've got the annotation on? Yeah. Okay, so I should email Jason that the annotation seems to interfere with cursor control. All right, so why does this work? How do we justify it? Well, the definition of a function is that each x has unique output. So there is only one y possible for a given x. That means a vertical line will only intersect it once. All right. And another quick check on the answer key here. Name, describe, and justify are 1 mark each. All right. Next up. Water is pouring out of your kitchen sink at a rate of 500 milliliters per second. How much water will it pour out in 7 seconds? Express your answer in milliliters. That's just 7 times 500. Determine the value of y such that the line containing P89 and Q4y has the slope 3/4. So our slope I'm not sure why it's going to the zoom. I don't want the zoom. I want this tool. So y equals mx plus b. The change in y is going to be, I'm going to call that y minus 9. Having y first makes the algebra coming up slightly simpler. And that is going to be over 4 minus 8. So this tells us that 3/4 is y minus 9 over negative 4. Multiply both sides by negative 4. We end up with negative 3 equals y minus 9. Add 9 to both sides, and we have a y equals 6. So the point connecting these, we can double check this. The point they gave us was 8, 9. So we can go y minus 9. We can just write this in our slope point form. All right, and we are comparing this to, we want to find the y when x equals 4. So when x equals 4, y is 6. We could also do this with a table of values on our calculator. We can graph it with that y minus 9 equals 3/4 x minus 8 and find the table that corresponds here. We could have even used this as our point form, the y minus 9 x minus 8, and put in x is 4 and solve for y here. It would have been virtually identical algebra. We'd still have that 4 minus 8 being multiplied by the 3/4, then we'd add the 9. So it's another way to arrive at exactly the same thing because the slope formula is how slope point form is derived. Regardless, that's a 6. So, which of the following statements best describes the slope of the line y equals negative 8? That we can graph. Notice it's not negative 8x, it's just y equals negative 8. That's our green line. It's horizontal. If x doesn't appear, it has the same value at every point. That makes the slope 0. Now the slope of this line, our change in y is a negative 2, when our change in x is 4 going between those 2 points. So if it's down 2, right 4, that slope is a negative 2/4, which simplifies to negative 1/2. Now the equation of this vertical line passing through the point 3, -4, well, all vertical lines are x equals the x coordinate. So that is x equals 3. All right, answer key looks okay. Moving on to RF4. So we want to find the x and y intercepts. The y we can read off. It's in slope-intercept form. So our y-intercept is -20. For our x-intercept, we let y equals 0 and solve. So we have 0 equals 8x minus 20. Add 20 to both sides. Divide both sides by 8. And when we simplify this, we'll have our x value. Simplifying 20 over 8, they're both multiples of 4. So that's a 5/2. We always want to make sure that's what x equals. And it specifically says answer in fraction form. It doesn't have to explicitly say that at this level because we have no decimals in the question, so we don't have permission to use decimals. Similar idea, x and y intercepts here. The y-intercept, again, we can read off, that's 20. X-intercept, if y equals 0, when we subtract 20, we have a -20 equals -5x. Here, x is 4. Exactly the same process as the last two. And now, the output value is 90 less than 2 of the input. Of means multiply. Less than means we're subtracting. So we take 2 of the input. It's 2 times x. And that 90 is, or it's 90 less than that. So we get our 2x, then we subtract 90. And that gives us b here. Answer key still okay. We are halfway through the test. Okay, so the domain and range of this graph using set or interval notation. I will do both for the answer key. Interval notation. That's greater than, less than. Here, our domain. Is x is greater than or equal to -3. Right, and that is the same as saying, or that's our interval notation. Our set notation is that x, and I'm trying to remember which is the member of symbol. Okay, so x is an element of the set. On the left, we have a square bracket. On the right, it should be round. I should actually check the brackets to see if we have a left square right. We do have a left square right round. So I shouldn't have used keyboards for that. I should have used this one. So our domain, all allowed x values, it doesn't get less than -3, but it can get as high as we want. For range, that one in interval notation, so that's greater than, less than. Okay, I'm not sure why this is. There we go. Y is greater than or equal to. Oh, no, it's not equal to. It's y. There's an open circle, so that's y strictly greater than -4. Or in the interval notation, y is an element of the set. And this is actually going to be round on both sides because -4 is not included. And it goes up to infinity, which is always on a round bracket. So strictly speaking, the curriculum just needs that interval notation. That's the one we did in class. Normally the rest come in set notation later on. Here we have exactly the same type of question with a very different graph. Our domain caps out. The upper limit is at x equals 7. So I'm going to say x is less than or equal to 7. And our range is going to be y strictly less than +7. So they're both limited at 7 this time. Okay, in the domain of this relation, the list of all allowed x values, it's just going to be a list. It's got the curly brackets to be part of a set. So, and again, we're just going to quickly mark our written response to check our answer key. Yep, so far so good. So a line and slope point form is given by this equation. A point on the line is. Here it's plug and play. So we could, one way to solve it, substitute x and y. Does your left-hand side equal the right-hand side? In this case, it does. When x equals 4, the right-hand side is 0. When y equals -5, the left-hand side is 0. 0 equals 0 is a true statement, so this is a point on the line. We could graph it, and that's another approach. We have y plus 5. Okay. So y plus 5 equals 6, x minus 4. And then our 4 points are 4, -5, 5, 4, 4, 5. 4, -5. That's our red dot here. That's a point on the line. 4, 5. 5, 4. And -5, 4. Only that one point is on the line. That's the other approach. You can graph it and check the graph. See if the points are on the line. Given that the slope of a line is -3/5 and the y-intercept is 4, the equation in general form is. So, here we go. So our slope is a -3/5, and our y-intercept is 4. Now we want the equation in general form, so we convert. Step 1, we multiply by the biggest denominator we see. That cancels the 5 here, so we have a -3x, and 4 times 5 is 20. Now we have to make sure the coefficient of x is positive, or it's not properly in standard form. So adding 3x to both sides cancels the -3x on the left, or on the right, sorry, and adds a positive 3x on the right. We have no denominators, we have a positive coefficient of x, and we have no factors in common with all three of our numbers. Yes, 5 and 20 have a 5 in common because we had to multiply by the 5. 3 does not have a factor of 5, so we're good. The only common factor is 1, because 1 is always a common factor, but the rest is good. So we are looking for 3x plus 5y equals 20, or 3x plus 5y minus 20 equals 0. So the slope point form of the equation in this graph, well, for starters, it's going up. So we have to have a positive slope. That eliminates options A and C. Now, B says the point 6, 10 is on the graph. But no, this has 6, 6. -6 and -10 is on the graph, so it's D. Now here, the equation of a line is 1/2 x plus b and passes through the point 4, 7. The value of b is. So we have 1/2 x plus b. So y equals 1/2 x plus b. That means b will be y minus 1/2 x. And it goes to the point 4, 7. So we substitute our 4 and our 7. And 7 minus 2 is 5. So our b has to be 5. Now the slope of this line in fraction form, displaying both a numerator and a denominator, is. So the best way to get a slope from our standard form or general form is to solve for y, or isolate y, is a more precise way to phrase what we're doing. Solve for y technically means come up with the value, and we're not doing that. I should have said isolate y. So if we want to get y on its own, our first step is adding 8y to both sides. We have a negative 8y here. That'll cancel, and we'll introduce an 8y on the right. Then we divide everything by 8. The coefficient of x is our slope, so our slope is 3 over 8. Okay, now on to RF7 with an answer key still in total agreement. A line goes through these 3 points. The equation of this line is... Okay, so what we can do is substitute in our first one here, or 0, 6, that third point, is going to be the easiest to substitute. When x is 0, does y equal 6? Right off the bat, we've eliminated options A and C. That leaves us with B and D. The next one to try is 4, 8. When x is 4, does y equal 8? It does in B. It does not in D. That would be a negative 8 plus 6 would be a negative 2. So we've already got it down to B without using the first point, because a line is completely defined by any 2 points on it. Now, in a different multiple choice setup, these 2 points could have been on one of the lines, but not the third. Although, I say that out loud, but now that I think about it, then it wouldn't be a straight line. Because once two points completely define the line. So if any 2 are on it, all 3 have to be on it. It's good to double check, because that will tell us if there's a problem with the question. When x is negative 10, this gives us negative 5 plus 6, which is a positive 1. All right. The slope point form of the equation in the line shown could be... All right, so we know it's coming down, so we have to have a negative slope. That gives us A or D. It cannot be B or C, because those slopes are positive. Now, A goes to the point negative 6, positive 2. When x is negative 6, y is positive 2. Could be that one. B gives us the point positive 6, negative 2. Can't be that one. It's a miss. Now, a line passing through the point negative 4, or a line passes through the point negative 4, negative 5 with a slope of 4 over 3. So let me zoom in a little here so we can read the graphs better. Negative 4, negative 5. That one goes through the point. What is our slope? 2, 3, 1, 2, 3, 4. That is a slope of 3 over 4. We need 4 over 3. So we need something a little bit steeper that goes through that point. So I'm going to try negative 4, negative 5, and 4 over 3 in D. Negative 4, negative 5 works. We go 1, 2, 3, 4 up, 1, 2, 3 right. That is still an intersection. So that works. Now the equation in the line and slope intercept form. We are going to have a slope of 4 over 3. And we see it passes through with a y-intercept between 0 and 1, closer to 0. In multiple choice, that's enough to jump here. A is in slope point form, and it is a correct expression for it. We could multiply 4 over 3 through here. We'd have the 4 over 3x plus 16 over 3. When you subtract 5 from both sides, 16 over 3 minus 15 over 3 is a positive 1 over 3. This has the wrong y-intercept. That matches this first graph where we had a slope of 3 over 4 instead of 4 over 3. And then our third one is not in any of our regular forms. And our last one, a line has a slope of negative 5 over 6 and a y-intercept of negative 2. When the line is written in the form ax plus by equals c equals 0, the value of b is. Okay, we have a slope of negative 5 over 6 and a y-intercept of negative 2. Okay, so y is negative 5 over 6x. Y-intercept is a negative 2. multiply both sides by 6. Add 5x to both sides. To get it completely in the requested form, we add 12 to both sides. Although, because this is multiple choice or numeric response and only asking for B, whether we got C right or not, it didn't actually matter. Okay, we are still good with the answer key. Now, so given the equation g of x equals negative 55x plus 92, where g of x equals 147, the value of x is. Now, be careful here. They're not saying x is 147. They're asking for x. They're saying y is 147. So here, we have 147 equals negative 55x plus 92. We can subtract 92 from both sides. Give us 55 equals a negative 55x. Divide both sides by negative 55. And our x equals negative 1. Yes, you have oodles of boxes because we need space for someone to make a mistake with something like negative 147 over 92. Now, given the following functions, the value of f of negative 4 is, so we put negative 4 in here, 4 times a negative 4 is a negative 16, minus 6 is a negative 22. But it looks like we have a negative outside the bracket. Yeah, okay, I'm going to have to remember to manually score that one. Because that, or, no, I haven't built your questions yet. When you see it, that negative will not be outside the bracket. I'll incorporate it in the answer already. This is another one given y. Find x. 44 plus 30 is 74. Divided by 2 is 37. Okay, so now, given the equation y equals x squared plus 50, if the input value is negative 1, well, negative 1 squared is positive 1. 1 plus 50 is 51. And given this, determine the value of x when h of x is negative 3. So if y is negative 3, we add 9 to both sides. That gives us 2x equals 6. X equals 3. Now, solutions to a system of linear equations. So we are now in the last 3 where people are potentially testing ahead of where we are in class. So I don't want to spend a huge amount of time on that in the solutions. We're going to go through all the notes later, so it should make sense. So for now, I will do the graphical methods that we have had so far. You can graph it. Of course, on the test, you'd have to isolate your y first because we don't have access to Desmos on our tests. We have our regular TI or Casio graphing calculators. And 5x minus 3y equals 3. There's our intersection, the point 6,9. So it's 6, 9. We put them side by side. Now, choose the row below that correctly gives the number of solutions for this system. We have on this one, so either they are the same line or they are different lines. You'll notice that first one, everything is even. If we divide it by 2, we have a 3a plus 2b equals 5. Multiply that by 3, we get the second line. They are identical. If you isolate either a and b in one and simplify it, you will have an identical expression in the other. Or even just say the first one, everything's a multiple of 2, The second, everything's a multiple of 3. Take out those common factors. Bang, identical. That means there's infinitely many, which is a line that overlaps in the graph. Now here, the solution to this graph is that x equals 3, y equals 2. Now, a student wanted to use elimination to solve the following system of equations. That's where we eliminate variables. We have to be careful here. There's a negative 3y right above a negative 33. It's so tempting to say we're multiplying by 11, but this negative 33 doesn't have the y. The negative 12y has a y. So that one would be 4. If you multiply this by 4 or negative 4, I'm pretty sure I've keyed it to both. A plus or minus 4 would work to cancel out our 12y's, or eliminate our 12y's. So now we have this system. This is built much more like we can graph in our calculators. We could also just equate the two and have 6x plus 7 equals 11s plus 1. Subtracting 6s from both sides gives us a 5s plus 1 equals 7, or a 5s equals 6. So that means 5s equals 6, so s is 6 over 5. Or because here we're explicitly told to use decimals, that's a 1.2. Now in that case, if s is 1.2 or 6 over 5, this is 36 over 5 plus 35 over 5. That's a 71 over 5, which is a 14.2 if I'm doing my mental math correctly. Answer key agrees, so I trust that I am. All right. Now, our measurement using reference. So the thickness of a quarter would be the one in millimeters. Right. The length of your bent thumb. The bent thumb is probably closer to 1 inch. The length of a cell phone doesn't really fit any of these. The distance jogged in 10 minutes is going to be the closest fit. Why did I put 3 for the thickness of a quarter? Sorry. That one should have been a 1. 3 is the distance jogged in 10 minutes. That's going to be closest to a kilometer. Now, which of these would be closest to a meter? That's going to be the height of a doorknob. So the difference between these two measurements is 6 and a fraction a over b. That's because the first one is 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 divisions. So that's our denominator. So there's 8, 9, 10, 11. So 10 and 11 over 16 minus 4 and 2 over 16. 11 minus 2 is 9. So this is 9 over 16. That's the fractional part. Now our best reference to estimate 20 centimeters, that's going to be the length of a math textbook. 20 centimeter dinner fork would be awkward. That might be more like a salad fork, as in like salad tongs. You're serving the salad with it, not eating the salad off of it. 20 centimeters would be a narrow classroom and a huge smartphone. So the length of a textbook is the best fit there. And the best imperial unit for measuring the length of a school table, that's probably going to be yards. Too small for miles, too big to really be comfortable with inches. And centimeters is non-imperial. Length of a school table that fits only a binder, and that's imperial, that's going to be closer to inches. All right, now I need to double check something, because this is saying So just looking at the answer key, one of these is not being marked correctly. And it is in measurement 1. So I am going to go down, try to find the one that disagrees. Okay, and it's actually the length of a school table. I'm going to see if they want inches for that too. They did. That's what it's keyed to. But the school table, especially in comparison to the school table that fits only a binder, I'm going to disagree on that. Okay. All right. I will adjust that before you guys see this. So that's 2 questions that need adjustments. Now, finally, our last curricular outcome, again, only for those who are requesting early assessment. So we want 12 Celsius in Fahrenheit. So that's 12 times 9/5 plus 32. We can run that through our calculators, and they're asking for the nearest hundredth, so we have permission to use decimals. That's 53.60. Now Fahrenheit to Celsius. Well, 32 Fahrenheit minus 32, that's 0. It does specifically say round to the nearest hundredth. Okay. Now convert 4,000 millimeters into meters. That's 4.01 rounded to the nearest tenth. 48 inches into millimeters. Now here we have the conversion factors built into the question as well. So 48 times, well, if it's 1 inch is 2.54 centimeters, it's 25.4 millimeters. So that would be 1219.2. 10 feet into meters. They're saying 1 foot is 0.3048 meters, so 10 feet would be this times 10. 3.048 is to the nearest thousandth. And 48 inches into centimeters. We've already done it into meters. So hopefully we have done those consistently. All right. So there we go. 70 out of 70. This solves our test.